Good morning. We were discussing about the various methods for cleaning the insulators in the field and in substations. This is to see that the insulators or the insulator strings are properly functioning during the energized conditions. So, we discussed various methods of cleaning both in energized conditions, that is live line washing methods, and also the de-energized situations where the cleaning is being done. So, various techniques were discussed about the cleaning aspect. So, the polluted insulators should not be left unattended. For the better performance of this, several techniques are being employed. So, one among them is the coatings. So, apart from cleaning, coatings are also being used for protection of overhead network equipment. These equipment could be the insulators, the conductors, or other electrical power equipment which is being employed for the overhead power transmission and distribution purpose. And in particular, the coatings gains importance during the winter conditions, as in winter conditions the insulators become wet because of the fog, rain, mist or snow conditions, and these contamination which happens in winter will have to be addressed. So, there are prescribed methods, standards which have been originated, which have been recently being discussed in several CIGRE working groups. One among the group is B2.44 which looks into this aspect. The CIGRE reference 631 which gives the coatings for protection of overhead power network is a very important subject for the utility engineers and also the transmission people who are working in transmission networks. So, we will discuss about some of the importance of coatings, where is the necessity for coatings, what are the types of coating methods which are being recently employed for the in particular to the insulation. Briefly we will also look into the conductors, but the main target will be the insulator coatings, various types of coatings which have been implemented or which are being used in the better performance of the overhead power insulators, particularly insulators ceramic glass or polymer type of insulators. So, this when a condition is being mentioned in winter conditions. So, in winter we see the temperature coming very low, the formation of ice happens. This ice frost which develops on the conductor and insulators is not a good aspect for the transmission or utility personnel. So, lot of time, revenue and the maintenance is required. So, this are a few examples of the ice accumulation on various transmission networks. You can see the temperature freezes, then the ice accumulation between the petticoats and the bridging of the live conductor do take place because of this condition. So, the maintenance of this has to be carried out and the formation of ice has to be eliminated. These are again a few of the methods which are being employed for the conductors and also the insulator. You can see the ice accumulation on the insulator string. So, this creates a mechanical weight on the transmission conductors. This further aggravates the situation where there are cases the towers get collapsed because of the mechanical loading of ice or ice loading on the conductors or insulators. Cascading with the wind, the tower could collapse. So, there are few examples which have noticed the collapse of towers because of the ice loadings. So, ice loading in winter condition is a serious issue which has to be tackled in many countries, in particular to the conditions in cold countries, in particularly where ice formation is noticed. So, lot of effort is being made to see that. So, in such cases whether the coatings which are being employed will be useful, we will look into this aspect. So, CGRE 3631 as I mentioned is the working group. B244 looks into the various aspects of the coating for the winter conditions, both on the conductors as well as the insulators, various types of insulators. It could be ceramic or glass insulators or a polymer type of material. So, with this background we would like to just focus on the coatings. So, we know that advances in material engineering have resulted in the development of advanced coatings. This we have seen to provide better surfaces with the better desirable properties. So, one of the coatings or the application of this coating have also been found in the aerospace industries, in particularly to keep the surfaces free of ice. So, here the surfaces which are found in aerospace applications, like the windows of the aerospace vehicles are supposed to be clear from the fog and the deposition of the ice. So, here some coatings have been employed to provide better properties to the glass there, and this architecture is mainly to provide the self cleaning properties for the windows in case of the aircrafts. So, the advanced coatings, this can provide surfaces with other properties like resistance, scratches, corrosion and chemicals as well, and they should be super hydrophobic in nature. So, these coatings can potentially benefit both the power that is electrical power industry, which when the self cleaning or a super hydrophobic property material or the coatings are done and are particularly better for the application in case of insulators, that too for a contaminated or a polluted environments, and also the ice loading conditions as we discussed. So, the ice repelling qualities of the coatings is a welcome suggestion where the performance in particular to the cold climatic conditions could be tended. So, the high loading or isophobicity which once these coatings are done, this could reduce the risk of flashovers as accumulation of ice gets reduced, and the flashover also because of ice formation is reduced. So, isophobic coatings are of very interest for application to the conductors, high voltage conductors, and also to the supporting structures, mainly to reduce the mechanical load, because I mentioned that accumulation of ice deposits on the insulators, conductors, supporting structures will mechanically load these structures or the conductors, and there could be a tower which could collapse because of the loading. So, this mechanical load due to ice accretion in winter, particularly in winter periods, have to be attended. So, isophobic coatings could come in a better way to stop the loading of the ice on these structures. So, the application of super hydrophobic coatings to conductors in particular may also have a better potential to reduce the noise, that is basically the electrical noise, audible noise, what we call audible noise because of the transmission conductors or transmission hardware, or due to the corona control rings or any other hardware which is in the transmission network. So, this create an audible noise, and also the radio interference and corona loss can be addressed because of the better coatings which could be employed on the high voltage transmission lines. But this has not yet been fully achieved or not yet been fully obtained. So, such coatings will definitely help to reduce the audible noise, RIV and corona on transmission lines, as and also the necessary accessories and insulators and so on. So, the benefits not only have the potential to increase the reliability of transmission equipments or assets, but it may also enable a reduction in the capital cost of the new construction. So, a lot of maintenance cost which is being diverted to the maintenance during the winter conditions in case of the better coatings are available. So, this could decrease the revenue scheduled for the maintenance. So, before applying any new breed or any new type of coatings, utilities or the power transmission companies need to be confident in their performance and their life expectancy. So, directly going in for coating without knowing the performance may not be the right conditions. So, better prior information, aging characteristics of the coatings have to be studied and have to be implemented in the field conditions. So, critical factors for these coatings, in particular when aged, that is over a period of time, aging could be of the environmental conditions, and the long performance it has served may not result in reduction in the performance below the uncoated surfaces. That may not require a high level of maintenance in the long run. So, several factors have to be considered before the coatings are being planned to be carried out on the insulators or the conductors, and also the application in particular to the better to maintain better hydrophobic or a super hydrophobic conditions and isophobic coatings could offer a number of opportunities to improve performance of the electrical power system. So, the major advantage of going in for the better property coatings is to see that the equipment performs better in the long run in the field. So, briefly there are classified as insulator icing, because we are looking into the conditions of winter. In majority of the cold countries, insulator icing is the critical issue. Again, the conductor icing settles on the conductor surface, conductor loads, and this is also an issue. The structure in the tower where the tower carries the conductor insulators, and here also the structure also is loaded with ice. Then further to that, apart from the icing, there is an insulator contamination because of the dust, because of the chemical, because of the farming activity, fertilizers, many of these things which we have discussed. So, there could be insulator contamination and also the corona from the conductor, radio interference and corona from the conductor. So, these important issues have to be looked into, so that a necessary coating or better coating could bring down this issue which are being mentioned here, like icing and the conductor contamination or insulator contamination, or the corona which is being generated because of these contaminations. So, in cold climatic regions, the performance of insulators particularly to ice or snow conditions is of a serious concern. As the cold countries, we have seen that the ice accumulation on the insulator surface makes the insulator wet and surface gets conducted. So, once the surface of the insulator gets conducted, the discharge activity from the high voltage end towards the ground end progresses, and depending upon the surface conditions there could be a flashover and a outage. So, service experience in the field has indicated that any electrical outage due to flashover is one of the greatest threat if the ice or snow accretion, that is a snow or ice which is collected on the surface, this is again followed during the period of melting. So, once the ice starts melting, the surface becomes conductive, and this conduction helps in the discharge activity, and the flashover of the insulator string is noticed. So, the main service cases could to be attended are to clean the insulators particularly covered with the conductive ice or a snow, pre-contaminated insulators or polluted insulators covered with ice or snow, or combination of the above conditions. So, in service during the winter conditions, these 3 or 2 conditions have to be addressed for the better performance of the insulator strings in the field. So, without interruption for the power supply for the consumers or the utilities have to be taking care of such conditions in particular in winter. So, when you look into the surface properties during ice loading, we have seen that anti-icing properties decreases ice adhesion and accretion on insulators. So, this will improve once the ice accumulation is being removed from the insulator surface. This improves the flashover performance under icing conditions, which the property is also referred as isophobicity. So, isophobicity is the performance of an insulator string during the icing conditions. So, better performance in icing conditions. So, a semiconducting layer that conducts a low level of leakage current approximately around 1 milliamp, heating the insulator surface to just above ambient temperature could prevent frost formation, that is the ice accumulation on the surface could be prevented by a leakage current of 1 milliamp which heats the insulator. So, this also grades the voltage distribution along this insulator, hence promoting the formation of more uniform ice accretion. So, proper voltage or potential distribution on the insulator surface makes it better perform. The electrical stress grading, that is on the insulator grading, also delays the arcing activities in case of long insulator strings. So, better voltage distribution will help the delay in arcing activities across ice free zones or dry bands in case of contamination or polluted conditions. So, the utilities on porcelain insulators generally use semiconducting or a resistive glaze which is being well established. So, this semiconducting glaze or a resistive glaze which is applied on the surface acts for a better voltage distribution and also will never allow the droplets or the formation of ice accumulation on the surface. So, semiconducting glaze, resistive glaze is the initial methods which have been practiced by the utilities. Then comes the room temperature vulcanized silicon rubber coatings, that is RTV coatings, which are generally termed. These coatings are also being used for better improving the contamination flashover performance on the insulators and are applied as a countermeasure against ice and snow activity where during winter conditions. However, effectiveness of the above coatings, that is a room temperature vulcanized silicon rubber coatings, semiconducting glazes or resistive glazes will reduce as temperature decreases, and therefore use to prevent insulator icing is again a problem to be addressed. So, how long the coatings survive or what is the life of these coatings in winter conditions and particularly to the icing conditions or the snow accumulation conditions, how long these coatings will serve the purpose. So, further to this efforts were made by many companies and also the researchers to come up with advanced coatings with isophobic properties which could be more attractive and better perform and improve the flashover performance of insulators under icing conditions. So, several of these mechanisms are being tried and are being used and are being developed. So, anti-icing or de-icing methods are few, which like anti-icing are basically divided into 4 major categories. One is the passive methods. These are based on natural forces or physical geometries. We will discuss about these importances of each of the methods. Second is the active coatings and devices which require some electrical energy to be effective on the coatings, so that the accumulation of ice or snow is prevented. The third is the mechanical methods. This is generally to see the formation of ice and the ice breaking down from the conductor or the insulator. The fourth is the thermal methods. Again here the temperature is being used to see the technique based on the temperature the ice is melted on the conductors or the insulators. So, these methods in detail are discussed in SIGRE 437 technical brochure 437. So, further details can be seen in this brochure, where they have comprehensively attended to the various methods of the passive, active, mechanical and thermal coatings. So, here you can see few of the examples here during the conditions where the surface of the insulators or the surface of the conductor where the discharge activity is present here. This shows that the droplets get accumulated over the period of time. Slowly the dust could form, and this dust can again contaminate the conductor or the insulator in the long run. So, this has to be prevented in the field. So, passive methods are one of the method which do not require an external source of energy, but rather they use natural forces such as wind, gravity or solar radiation or phase circuit geometry to achieve different strategies. So, they are not direct methods of passive methods. So, weakening of ice adhesion strength, preventing freezing of supercooled water droplets on impact, using a combination of specific devices for limiting the impact of ice overload on conductors, and exploiting natural forces like wind, gravity or solar radiation in order to limit the adverse effects of ice load on overhead transmission lines or insulators. So, these are all the passive methods which have been mentioned here. So, some of these methods are already being used and are effective for wet snow, but their efficiency for ice conditions needs to be still monitored and studied. The next is the active methods. Active methods we will be discussing about the active techniques and methods which are being used for the insulators and also the conductors. The third is the mechanical methods. Again the mechanical methods refer to any method involving breaking of the ice which is formed on the surface of the conductor or insulator. This is mainly to see that to accelerate the ice shedding which is being loaded on the conductor or insulator. In most cases the mechanical methods which are being used can be considered mainly to see that de-icing takes place, as these used are to speed up the shedding process after the snow or ice accumulations forms on conductors or ground wires, so that removal of ice or de-icing is being done. The fourth is the thermal methods. Here again this includes all non-natural methods, here causing the ice to melt in order to force shedding. This method consists mainly in heating of line conductors or ground wires to prevent ice accretion or for de-icing purpose. The temperature of the conductors is raised or the ground wires is raised to prevent the ice accumulation on the conductors or the ground wires. So, we go to the coatings, the importance of coatings or the classification of coatings. So, coatings which are being developed, which are being used, as mentioned earlier, they could be active or passive depending upon their need of external energy or not to start their operation. So, active coatings What are these? Active coatings require basic some electrical energy. To be active, a few active coating techniques are being employed. Notably, active coating has been developed. In general, these methods are applicable to conductors. However, some semiconducting coatings are also being used for insulator surfaces and can also be categorized as active coatings. So, presently for conductors and also for insulators, these coatings are being used. Passive coatings, as mentioned earlier, passive coatings are the ones which do not require the energy to be activated. Here the case of super hydrophobic and isophobic coatings, low surface energy and surface topography are among the properties which reduce or prevent adherence of water and ice on the surfaces. So, theoretically isophobic coatings prevent ice from sticking to the surfaces. This is the important point for a passive coatings. The ice should not stick to the surfaces, either a conductor or the insulator, because of their anti-adherent property. So, while super hydrophobic coatings do not allow water to remain on the surface because of their repulsive features. So, this is like a hydrophobic coatings which are much better above the, it does not allow the water, more repellent water repellent property is being embedded in the super hydrophobic coatings. So, which do not allow water to remain on the surface. So, coming to coatings for insulators. So, previously coating for conductors are also being available. So, we will focus on the insulators part. So, coatings on insulators are mainly used to see that insulator flashover under both pollution, contamination or icing has received a great deal of attention from many researchers. A large number of studies have also been carried out in several laboratories. The development has taken place. A large number of utility personnel, transmission companies and so on. So, to optimize and maintain the outdoor insulation is more of an art than science learned through long life experience. So, better experience gives us the information for the maintenance and optimize the methods. So, methods like high pressure washing, which we have discussed during the cleaning process for insulators and other equipment. So, methods like high pressure washing, silicon dielectric application of silicon dielectric greases, removal, then RTV silicon coatings have all been applied to porcelain and glass insulators, which are being followed for a long period of time. So, these coatings perform better in the initial period of time and silicon rubber housings, particularly RTV, high temperature vulcanized, room temperature vulcanized and liquid silicon rubber, LSR is liquid silicon rubber. So, these housings have proven to be more effective, offering much better long term capacity to provide the anti pollution or contamination properties. More recently, RTV silicon rubber coatings have successfully been applied to the porcelain and glass insulators in order to improve their pollution performance. This happens at a higher voltage above 400 kV, where pollution or a contamination is a serious threat for both AC and DC transmission systems. So, applying RTV coatings to glass or ceramic insulators have shown better performances of these insulators in the field. So, the search again continues for new technologies. This could offer both technical and economic solutions for the improvement during pollution conditions. So, this specifically includes coatings for insulators, not only for porcelain glass and also polymer type of insulator to improve their flashover performance under contaminated or ice loading or snow or a combination of these conditions. So, these coatings could provide better self cleaning properties, prevent dry band arcing or a scintillation activity and improve the voltage gradient or reduce high ice adhesion and accumulation of ice on the surface of the insulators. So, such coatings are being developed and are being practiced, and also lot of work is been in progress to develop better coatings for the transmission insulation. So, one of the example here shows the coating of the insulators on the bushing on the substation where it is being attended. So, our room temperature vulcanized coating is being done on the surface of the sheds of the porcelain high voltage bushing. This in the transmission system or a distribution system, this could be a CT or a PT bushing in the substation. So, various coatings we were discussing. So, the one false is the hydrophobic coatings. This is a important one as a common way to improve the contamination flashover performance of insulators is basically to provide the insulator external surface with hydrophobic, that is a water repellent property on the insulator surface, so that the droplets do not accumulate, contaminants do not accumulate over a period of time. So, hydrophobic surfaces which have low surface energy cause water to bead in the form of beads into distinct water droplets that inhibit the formation of continuous conducting film. So, the coatings made which are known as hydrophobic coatings makes the surface hydrophobic, that is water repellent, and sees that the formation of water droplet are in the form of beads or it is not in the continuous film. So, this will help in better performance of the insulator or insulator strings. So, some of the examples can be seen here. For a bare insulator, this is a room temperature vulcanized coating which has been done, and this is the without the coating. So, appearance after 30 minutes is given here. Again, this has been taken through the Segre brochure which has been shown at the initial starting of this talk. So, appearance after 3 hours, you can see how the insulator or the bare insulator after the coating, the performance is appearing here, where you can see the better performance. Similarly, RTV coated insulators, you can see the improvement aspect after 3 hours. So, these are the comparative icing appearances on bare and also RTV coated insulators for 30 minutes and for 3 hours. So, better performance is being noticed. The second is the super hydrophobic coatings. Here the surfaces with a combination of microstructure and low surface energy are known to exhibit super hydrophobic property. So, much better water repellent property than the hydrophobic aspect. So, even slight amount of water drops can restrain dirt particles adhering to the surface and clean the surface completely. So, it is known that if effective self cleaning is to be obtained on an insulator surface, the surface must not only be very or super hydrophobic, but also have a certain roughness. So, how this roughness is defined? So, the surface structure should be composed of protuberances and small depressions which are required for self cleaning purpose, and must have a spacing of in the range of 50 nanometer to 200 micrometers, anywhere between this range, and a protuberance height ranging between 50 nanometers to 100 micrometers. So, here you see a comparative icing appearances on bare and super hydrophobic coated insulators for 30 minutes and also after 30 hours. You can see this is a bare insulator, this is the super hydrophobic conductor, super hydrophobic coating insulator for 30 minutes. Here you can see the appearance of after 3 hours. So, these coatings do help in better performance in the field. The third is a self cleaning coatings. Here the low adhesion force that is generated between the liquid droplet and the surface, when the liquid droplet falls on the insulator surface, the energy or the adhesion force which is being between these two can manifest itself in some interesting characteristics. So, such as cleaning effect, self cleaning effect. So, generally a surface is referred to as self cleaning when it can show somehow clean the surface by itself. So, on a hydrophobic surface where water repellent force is observed, so self cleaning is usually done by absorption and transportation of dust particles in a liquid droplet moving on the surface. So, the surface which is contaminated, small droplets move with the contamination. Therefore, self cleaning surface will remain contamination free in outdoor environments when it is exposed to precipitation. Clearly, self cleaning can be of great benefit for outdoor insulation, and therefore, several self cleaning coatings have been developed with electrical insulation in mind for all the three technologies, ceramic, glass or polymeric insulators keeping it in mind. So, several self cleaning coatings are also being developed. So, next is the active coatings. These active coatings are basically like the semiconductive glaze coatings which we have discussed. So, semiconductive glaze coatings, the benefits for going in is to see the improvement in the flash or strength or performance of the insulators, particularly under contaminated or polluted conditions and also under icing environments, and these have been established well with the coatings. So, the benefit is also derived from the heating and grading provided by the leakage current in the semiconducting layer which is done. So, the coatings which is done. Although these insulators work well under AC conditions, the semiconductive glaze coatings or application to DC is not yet recommended because of the corrosion issues and also the glaze destruction in case of DC application. So, this is one of the typical example of the temperature on the specimen here, that is the insulators. This is an ordinary glaze and this is the semiconducted closed coated insulator, ceramic insulator. So, anti-icing, the next is the anti-icing or a semiconductive silicon rubber coatings for the insulator strings with semiconductive coating. This helps in formation of no icicles and no ice covering on the surface of insulator. So, these are also being tried for the insulator strings where semiconductive silicon rubber coatings help the performance of the insulators by saying that the does not allow the formation of ice on the surface. Next we look into the methods for characterization of the coatings. So, we have discussed about various types of coatings like the room temperature vulcanized silicon rubber coatings for both the ceramic, glass and also the polymer methods, polymer insulators, but the techniques for polymer insulators are also being developed. So, presently for the bushings, substation hollow insulators and the transmission insulators, some of the coatings by the utilities are being employed and they are being used extensively, and some of the methods are also being developed. So, methods for how to characterize the coating is also equally important. We look into the methods, that is the test methods for characterizing the coating. So, here the coatings and the surface treatment should not only provide good functional properties, but should also have favorable intrinsic properties to fulfill their function. So, in this regard the following characteristics are important, that is the material, electrical, thermal and mechanical properties. So, all these properties are the methods to characterize the coating which is being used. So, intrinsic material properties like the thickness of the coating, how is this defined? So, what is the extent of thickness to be applied on the equipment, that is on the conductor or the insulator. So, here the thickness of the coating is a sum of all the layer thicknesses. So, thickness of any non-homogeneous layer shall be estimated as a maximum geometric size of the contained particles. So, thickness of the coating shall be measured according to the ISO standards 2808, and there are 8 ASTM standards prescribed D1005 and D4414 and other standards which give the information about the thickness of the material to be coated on the surface. The second is the density of the coating. This is again how much density, that is weight per unit volume of the coating, the surface of this length of the substrate. Again here density of the coating is done or tested in accordance with the ISO standards 2811 and ASTM standards. So, here it mentions about the density of the coating to be made. The third is the hardness. Again hardness is a measure of how resistant a coating is to be permanent deformation when subject to comprehensive forces. So, hardness depends on various material properties including ductility, elasticity, stiffness, plasticity, strain, strength, toughness, viscosity and viscoelasticity. So, all these properties are important in deciding the hardness of the coating which is being applied. So, for this again the measuring standard ASTM D3363 or the ISO standard 15184 is being referred. So, material properties which are being employed will also play a role in the that is the thickness, density, hardness to characterize the coatings. So, what are the recommendations for the coatings and requirement and testing is also an important task. Here at present there are no prescribed standards that directly apply to hydrophobic or isophobic coatings. So, various parameters are still need to be identified, investigated in order to develop suitable test methods to qualify such coatings. A lot of effort is being made by the manufacturers, by the researchers, utilities and many transmission companies to see that suitable solution is obtained or suitable procedure is obtained or coating is made or recommendation is done to see that this works better in the and improve the performance of the insulators or the conductors. So, general requirements for coatings is to see that an approach to identify requirements and suitable test methods should comprise basically like identify the suitable functional performance requirement. It could be an insulator or it could be a conductor or it could be any substation equipment. So, to determine the primary or the important and secondary less important degradation modes. The third is a design and implement a set of tests to evaluate the performance, that is once the coating is done, before the coating and after the coating the performance of the equipment or the insulator or the conductor is to be evaluated and checked for its improved performance. So, the functional performance requirement could be the main requirement for coatings for protecting power network equipment in winter conditions mainly, or the functional requirement that is isophobicity, the repellent action of the ice formation on the surface, hydrophobicity, that is water droplets should not be forming on the surface on the insulator or the conductor, and it should be able to have a self cleaning mechanism where the formation of droplets or the contaminants which are being spread are to be able to clean up on its own, that is a self cleaning property. Then durability or longevity, again how long the performance of this coating exists, so is also equal importance. Then the economics, that is the cost effectiveness, how much is being invested for the coatings and how effective it is, cost effective is also important, and ease of application. So, the method or a technique which is being employed for the coating. So, how easy is to implement or use the coating for the insulators, conductors or any of this equipment. So, several of these functional performance also play role in the insulation or the conductor coatings. We look into the summary of passive coatings for insulators. Here again we have various parametric which are shown here. The main chemical composition is on the first column, the second is the deposition of the techniques, the third is the properties and application, the fourth is the durability, the fifth gives the information about the comments which are being done for a long period of time. Taking the example is the RTV silicon rubber coatings. This can be either done by a spray coating or using a brush type of method. So, basically this is used to see the hydrophobic property is improved. The durability is said to be 10 to 15 years, and this method has been well established technology for polluted or contaminated conditions, but not an effective under icing conditions. The second is the PDMS resin plus silicon oil plus silicon dioxide nanoparticles. Here again they use a spin type of coating, which is mainly to see the properties of hydrophobicity are improved. Here it is being in the development stage or not fully tested and proven technology. Here again mainly targeted for ice adhesion strength was calculated from the direct synthetic atmospheric icing of the insulators. So, several of these things again combination of various materials, chemical composition are being used to see mainly for and this is the various methods which are being employed, and some are being developed and some are being used and not tested. You can see some are not tested and some have better properties initially, but in the long run the performance have to be verified. This is again summary of the passive coatings for insulators. Here similarly various chemical composition of the materials are given here used for silicon dioxide, zinc oxide, silicon rubber. So, various techniques which are employed like plasma etching, spin coating, spray coatings, then several of these properties like super hydrophobicity property and self cleaning methods are because of this fluorinated hydro homopolymers and copolymers are being used. These say they have an excellent UV resistance, and various methods presented are to check to see the UV resistance of super hydrophobic coatings. So, again silicon rubber and silicon dioxide and zinc oxide coatings are also being employed to get the super hydrophobic or a self cleaning property. Here again super hydrophobic properties are retained after 10 days in a click and basic solution. Excellent thermal and UV resistance have been noticed, and some of the silicon rubber and stearic acid coatings are also being tested which are not being used in the field and they are being tried. So, again you have various fluorocarbon solvents and catalysis which are also being developed mainly to glass, polymer, ceramic and metal, and this has proved to be stable in multi-factor aging and UV resistant methods. So, again OH, PDMS and modified silica powder, that is a nano powder is being also used, like spray coating is being employed as a method. Here super hydrophobic properties being noticed and significantly lower accumulation of ice weight compared to the RTV coatings. So, this method also has been not tested, it is being tried out. So, icing test was performed in a climatic chamber of a treated insulator. So, several of these methods are being developed, various types of coatings, passive coatings are being developed for conductors, insulators for better performance. This is one of the method which has been shown here, icing appearance of the semiconducting glaze. You can see the appearance of the semiconducting glaze. This is an ordinary glaze. So, after the semiconducting glaze the ice accumulation is been drastically reduced. The second picture shows the thermal of the specimen in icing. So, this shows the uncoated sample, the left side, and the right side shows the coated sample which has been attributed in a better performance, showing in a better performance. So, several of these glaze ordinary semiconductor glaze and coatings are being used for a period of time in the transmission systems. So, summary of this passive coatings again, this has been repeated, has been noticed that lot of effort is being carried out and lot of effort is being made to see that the coatings are being used for both the ceramic, glass and polymer, effort by the utilities, researchers and also the manufacturing companies to come up with better methods and techniques, and also the durability in the field for longer sustainability. So, here we have tried to look into various coatings for the insulators which are being employed, and we have also looked into the cleaning aspects of the insulators. So, with this we end the importance of this topic on the coatings of the insulators. So, thank you.